Here's another example of a system of linear equations problem, or we start with a word problem that can be expressed as a system of linear equations, and then we'll have methods available to us to solve that system. So in this problem, we imagine that we have some money to invest, $30,000. And we've got three different types of investments: stock market, government bonds, and a money market account. And these each earn different interest rates. The stock will earn 7% interest, the bond 1% interest, and the money market 2% interest. Now at first it might seem like you should put all your money in the stocks because of the higher interest rate, but that's risky. That's the reason it earns a higher interest rate, is because there's some risk involved. You actually could lose your money instead. The 7% is just sort of a hopeful prediction. So in order to reduce your risk, you decide to play it safe. You're going to diversify your investments by using all three options, and you're going to put as much in the safe bonds as you do in the risky stocks to offset your risk. Now, you would like to earn $1,000 interest, even though you are playing it somewhat safe. So how much money should you invest in each account to hit this target? And this is assuming you can count on these interest rates of 7, 1, and 2% interest. So let's see how we could proceed. The unknowns in this question are how much to invest in each of the three accounts. So let's let X represent how much we're going to invest in stocks, Y will represent how much we're going to invest in bonds, and Z will represent the amount we will invest in the money market. Now we know the total amount we're going to invest is $30,000. So if we add up X, Y, and Z, that should equal 30,000. We also said in the problem description that we wanted to put the same amount in stocks that we do in bonds. So the amount invested in stocks, X, should equal the amount invested in bonds, Y. Now, if we're going to use the techniques for solving systems that we've discussed so far, remember we need to have equations where all the variables are on the left side of the equal sign, and any numbers that don't involve variables are on the right side of the equal sign. So in order to achieve that, let's rewrite this equation, x equals y, in the form x minus y equals 0. Finally, we know that we want $1,000 interest at the end of the year. So what we want to do is add up the interest we'll get from each investment. Now, X is the amount we're investing in stocks. So if I multiply that by 0.07, that represents the 7% interest we earn from the investment in stocks. Similarly, 0.01 times Y represents the interest we'll earn from the investment in bonds. And 0.02Z represents the interest we'll earn from the investment in the money market account. And those three sources of interest added together, we want to add up to $1,000. So now we have three facts here we've converted into three equations. Three equations with three unknowns. That's perfect. That's a square system, and we have options for solving such a system. You could set up an augmented matrix and use Gauss-Jordan elimination. For the purposes of this example, we'll illustrate how you could do it using a matrix equation and a matrix inverse. So the first thing we do is set up a matrix equation. Remember, to represent this system with a matrix equation, the right sides, the numbers that do not multiply variables, become the entries of the matrix on the right side, 30,000, 0, 1,000. And on the left side, we split up the coefficients from the unknowns. So we get a matrix where the coefficients of the first equation, 1x, 1y, 1z, become the entries in the first row. The coefficients of the second equation, it looks like there's no z here, but you can think of it as a 0z, 1x minus 1y plus 0z. That's where the second row of this coefficient matrix comes from. And finally, the coefficients in the last row come from the last equation. So that coefficient matrix times the matrix of unknowns should give us the right side. To solve this problem, we need to isolate the matrix of unknowns, the XYZ matrix. So we do that by multiplying both sides by the inverse. So remember, the point of multiplying by the inverse is that the inverse of the coefficient matrix times the coefficient matrix gives you an identity matrix. And so the new left side is just identity times XYZ, which simplifies to just XYZ. This matrix we've written here is the inverse of the coefficient matrix. So you could calculate that by hand or by using technology such as a graphing calculator. Once you've calculated the inverse, you multiply that inverse times the matrix that was originally on the right side, and that gives you 10,000, 10,000, 10,000. So let's interpret this. We have the unknown matrix XYZ equals 10,000, 10,000, 10,000. So that means X is 10,000, Y is 10,000, and Z is 10,000. And in the context of our word problem, the real world meaning is that we're going to invest $10,000 in each of the three different investment types.